Hello all, good morning. Today we are going to discuss about IP addressing. So it is a CCNA concept, uh, but uh, but we need clear-cut understanding on IP addressing. Though we are Windows administrators, but we should understand IP addressing clearly. At least we should have a basic understanding. Okay, so as part of course, we are going to discuss IP addressing basics, not in details. So like subnetting, we are not going to discuss, only IP addressing. I'll make you understand the IP addressing, how many classes, what are those. So we'll discuss today, okay? So IP address. IP address is a logical address. So why IP address is a logical address? Because it is not physically exist. It is a logically exist. See how the IP address looks like. I'll show you. ipconfig is a command to view the IP address in the system. See, this is the IP address. So this is not physical thing. This is a logical thing. So why we need IP address? Why we need IP address? Please mute yourself, guys. Please mute yourself. Otherwise, it will disturb the video. So why we need IP address? To communicate other systems in the network. Other systems in the network. So if you don't have an IP address in the system, you cannot communicate other missions in the network. Okay. So like without the phone number, can we communicate anyone? Can we communicate anyone without the SIM card in the phone? I mean, SIM card is a physical thing, number is a logical thing. SIM card is a physical thing, number is a logical thing. So here, NIC card is a physical component, physical hardware, hardware, and the IP address is a logical number. IP address is a logical address. So if you compare SIM card and number, here similarly, likewise, here NIC card and IP address. So let me, so this is the computer, okay? I mean, client mission, let's say client mission. We can call client missions. We should learn the terminology. So client mission. So don't call PC. So when you go to real time, they call client mission. They call client mission, not PC. Client mission. So if the client mission want to communicate at internet, let's say internet. If this PC want to communicate public network or any computer, this is the internet. Internet, WAN, public network, we can call public network. Okay. So if the client mission want to communicate internet, public network, then what the client mission should have? Primarily NIC card, right? So on NIC card, we need a IP address. IP address, right? So without these two, this is the physical thing. Physical thing. This is the logical thing. IP address is a logical and NIC card a physical. Like SIM card is a physical and mobile number is a logical. Can we touch mobile number? No, right? It is a logical. Can we see? We are transferring the money. So what we are transferring? Any physical thing we are transferring? Just numbers we are transferring. So that is logical. The money is physical, which we can touch. That is physical. So like NIC card is a physical, IP address is a logical. So mobile number is a logical and SIM card is a physical. So these two are at most important to communicate anyone, any mission, any computer want to communicate with any other computer in the network should have an NIC card and IP address. So IP address is a logical. Okay, it is a layer 3 IP address. So layer 3, what is layer 3? We will discuss tomorrow OSI layers. So then you will come to know what is layer 3. So as of now, let's by heart it. IP address is a layer 3. Layer 3, network layer 3 address is IP address. Okay, layer 3. I will tell you tomorrow's class, what is layers. Okay. Two versions of IP address. There are two versions of IP address available in the market. So that is IP version 4, IPv4 and IPv6. IPv4 and IPv6. So what is IPv4? This is a 32-bit address and it is a 128-bit address. So as of now, IP version 4 is using almost world is using IPv4 till now. So IPv4 addresses are sufficient addresses as of now. Any organization, what are the IP address they need, the IP version v4 is providing. So since many years, even when I was entering to the IT saying IP version 6 is going to come, IPv4 IP address are going to disappear because we need more IP address. But every organization or any organizations having a sufficient IP addresses from IP version v4. So hence the organizations are not using IPv4, IPv6 now. So there are two types of versions, IP versions, IPv4, IPv6. So we are not going to discuss about IPv6. So IPv4 we are discussing today. So IPv4 bit is represented zeros and ones. So how, see, the Linux, the mission language is binary. We are discussed in the demo class. The mission is understanding only binaries, zeros and ones, not human languages, readable language. The OS will translate vice versa. Okay, between human readable language and human readable language and binary language, right? So here this address also in binaries, zeros and ones. Then only system can understand. But actual our IP address looks like this. Like this. This is the IP address. Okay, but it converts binaries. Then only system can understand. Otherwise, system cannot understand. So this is IP address in binary, 32-bit. So like this. So this IP address divided into 4 octets. As I discussed yesterday, 4 octets. First octet, second octet, third octet, fourth octet. Okay. So first octet, 8 bits. Second octet, 8 bits. And third octet, 8 bits. And fourth octet, 8 bits. 4 into 8, 32-bit address. So 4 octets into 8 bits, 32-bit address. We call 32-bit address. Okay. So IP address in decimals. See, this is binary. So IP address in decimals looks like IP address in decimals, this is the looks like. So I shown you this. This is decimals. Okay. So total IP address range. So what are the IP address range? So there are IP address ranges 0, 0, 0 to 255, 255, 255, 255. In between, in between numbers, in between numbers, we can find IP addresses. In between range, so 0 to 255. So 0 to 255, in between numbers, we can see the IP addresses. So this is third 0, third 250, fourth, fourth. In between numbers, we can see the IP addresses. Okay. So IP addresses classifications are, IP addresses are divided into 5 types, 5 classes, not types, 5 classes. We should call classes. For make you understand, I'm using layman language. So that is the reason I'm also providing the notes. Okay. So the main goal is to make you understand. So that is the reason I usually use layman languages. Okay. So IP addresses are divided into 5 classes: class A, class B, class C, class D, class E. There are 5 classes. So class A, B, C, these 3 classes everywhere, organizations, educational institutes, software companies, everywhere, only the 3 IP addresses will be used. Only 3: class A, class B, class C. If you see anywhere, if you go anywhere and see the IP address in any organizations, they use only class A or class B or class C, either class A or class B or class C. So what about class D and class C? So these 2 classes we are not using in a day in any organizations kind of. So these 2 classes used reserved for multicasting, and D and E is reserved for research and development. So these 2 classes will use in any researching and development firms. They use these 2 classes. Apart from these 2 classes, you can see you can see your internet IP address, public IP address also in between 3, either A or B or C. So what is A address starts and from which number A class A IP address starts, from which number class B, and from which number class C starts, we'll discuss. So coming to priority bit. Priority bit used for IP address classifications. Most significant bits from the first octets are selected for the priority bit. So priority bit is 0. See here, 0. If you see priority bit, octet, first octet and second octet is priority. Priority bit is 0, priority bit A. Priority class B priority bit 10. Class C priority bit 110. Class D 1110. Class E 1111. These are the priority bits. Okay. And coming to ranges. So from which range to which range class A, from which range to which range class B, from which range to which range C. Let's see now. Class A. Class A range. This is the total range. Don't forget this. This is the total range. 0 to 255. 0 to 255. This is the total range. Okay. And class A range. Yeah. Class A range. So class A 0, 0, 0, 0, 0.0.0.0 to 126. See 0 to 126. In between IP addresses are class A. Class A. This is the class A range. Class A range is 0 to 126. In between, if any IP address starts from 0 to 26, in between, we can call that IP address class A IP address. Okay. And so let's discuss about the private range later. Okay. And class B. Class B is 128. Sorry. Class B starts from 128. But what about 126? Here 126, but what about 127? 127 is a loopback address. It is a loopback address, and we nowhere will use this IP address. But it is a default IP address. We can also call default IP address. If system doesn't have an IP address, even system has an IP address, but the default IP address is always hard coded in every mission. You cannot delete or you cannot escape. So this is the default address. It is a hard coded in the mission. If you see, this is my mission. So I run ipconfig. So this is one NIC card, and this is one more NIC card, and this is 3 NIC cards I have in this mission. These 3 NIC cards, each NIC card having IP addresses. Okay. But 127, this is a loopback address, as I told you, right? Let me ping this IP address. Ping 127.0.0.1. So this is pinging. Ping means packet internet grouper. Ping means packet internet grouper. So why we need to use ping means, for example, I have a mission here. Okay. So this is also one of the client mission. Client mission 2. Okay. See, there is a connection between 1 and 2. Okay. There is a connection. Okay. But connection means cable. See, the both are either 1 second. Instead of this, this is a switch. Okay. See, the both missions are connected to switch. Okay. Now, see, both have a physical communication. But if I want to check the communication from client mission 1 to client mission 2, then usually we use ping command. Ping, and what is this mission IP address? Let's give some IP address here. 192.168.223.10. Let's give 192.168.223.12. Okay. So 12 is the system client mission 1 IP address. 10 is the client mission 2 IP address. So the both missions are physically connected with switch. So now I want to check the communication from client mission to client mission 2 or client mission 2 to client mission. So then we use ping command. Then we use ping command to check 192.168.223.10. So we to check the communication, we use ping command. Ping command is to check the communication. So if we get this response like this, see, this is ICMP packets. We call these are the ICMP packets. Okay. So if you get this response, that means we have a communication. If you don't get this kind of communication, and if you get request timed out, let's say let's say 192.168.223.114. See, if we get a response like, see, destination host unreachable or request timed out, that means there is no communication. If you get the response like this, there is a communication. So ping is the only command to check the communication, vice versa, from here to here and 12. So from here to here, here to here, we can check the communication using ping command. Okay. So here the point is, see, request timed out is coming. Okay. See, IP config, but there is no IP address called 127.0.0.1 or, but why it is pinging 127.0.0.1 or 2? Any. See, why the 127 series is pinging? The system doesn't have this IP address. See, if you see the IP address, there is no 127 IP address. But since the 127 is pinging, so this is called a loopback address or default IP address, which is hard coded in the mission. And is there any use of this? Yes, there is one use as per my knowledge. So we can use this loopback address for only one thing. For example, if you want to check your NIC card, it is only single mission, only single mission. There is no network, nothing, only single mission. So this mission usually NIC card, okay. Okay, this client mission only standalone, single, having NIC card. There is no IP address. So there is no IP address. But I want to check whether the NIC card is working or not. Okay, I want to check whether the NIC card is working or not. Then you can run this. Then you can use the default. Then you can use default command ping 127.0.0.1 or any even 2 also you can use. Any series 127 series 10 also you can use. So if you get the response like this, then your NIC card is fine. Your NIC card is functioning. There is no issue. So like we can use loopback address to check the NIC card, whether the NIC card is functioning, working or not. Okay. So this is a class A range. Class A range is, 0 to 126, and this is loopback address 127.0.0.0.1 to 255. Okay. So this is only this called loopback address or default address. Next, coming to class B range. Sorry, class B range, it starts from 128 to 191. 128 to 191. And the class C range is 192 to 223. 192 to 223 is the class C range. So class D range is 224 to 239. And class E range is 240 to 255. This is class E range. Okay, anyway, you leave it class D and class E. Concentrate on class A, B, C. Okay, so coming to, so this is the class range, right? 0 to 126 and 128 to 191 and 192 to 223. Okay, you tell me. Please mute yourself, guys, please. Okay, tell me this class, which class IP address it is. You tell me, can someone unmute and tell me which class IP address it is? Anyone? Class C. See,
Class
this
C,
is,
sir.
yes, class C, 192. C, 192. Okay, and let me give you another example. 172.16 something. What is this IP address? Which class IP address it is?
Class B, sir.
Exactly, correct. And which class it is? Sorry.
Yes, sir.
Exactly, correct. See, like we should identify, we have to identify classes initially. That is a basic thing. If you identify the classes, then you can easily learn remaining part. So first, either you by heart it or make you understand yourself, but by seeing the IP address, you should know that which class IP address it is. Okay. Yeah. Coming to private range. What is the private range? Why we need a private range? See, here, I think in few years ago, there is a conflict, means IP address outage. I think you generally this IP addressing, the future visibility, because of future visibility, they made a separation from this range to total range to uh, they pull one range for private uses, because see, everyone using IP address. See, nowadays in across the world, billions of people are using internet. So each person should have an IP address, right, to communicate. Each person means, I mean, each computer. Each computer should have an IP address to communicate. Otherwise, they cannot communicate. So now billions of people using internet. So every user should have an IP address. Otherwise, they cannot communicate, right? So how we are, every person having a phone number, right? Without the phone number, we cannot communicate. Likewise, so they thought if everyone using IP address, then we may get outage. So uh, they thought pull the one range from the total range. Each class, they pull out one range from this total range. So this is a 10. 10 is a range 10.0.0.1. 10.25.25.25.25. So how the user outage will happen? So let's understand this. For example, in an organization, one second. Okay, let's say this is LAN, local area network. Okay. In LAN, in local area network, many computers. There are many computers, right? One moment. It's okay, many computers. In a LAN, in any LAN, we can see thousands, hundreds of computers. Let's assume these are the computers in the LAN. These computers, of course, connected like switch. This is a switch. Okay. Now switch, let's say connected router. Now router connected internet. Internet. Okay. So all the computers should have a public IP address to communicate internet. Public IP address, right? Let's say IP address, not public, nothing. IP address. IP address. Each computer should have an IP address. Then only they can communicate internet. Otherwise, they cannot communicate. Okay. So if we give IP address to each computer here, how many IP address? 12. 1, 2, 3. Okay, 4, 12. 12 IP address. So let's say assume TCS, Infosys, HCL, which we know the companies. So they are having 1 lakh, 1,50,000, and IBM is 2 lakhs, more than 2 lakhs. And so lakhs of people are working in the companies. So each laptop or a desktop should have an IP address to communicate internet, to get the internet, right? So if everyone using the IP address, what will happen? No IP address are available. For example, let's TCS. If the TCS is 2 lakhs, 3 lakhs employees, let's assume that many IP address is available in IP address v4? No. So to control the usage, to control the IP address usage, they made one plan, that is private range. From the total range, they pulled out this range. So they made this IP address are private IP addresses. So this IP address are cannot routable in the public network. So the IP address are not valid in the internet. Only for internal communication. For internal communication, why we need to pull this range from this total range? Still we didn't understand, right? Here, see, in the total range, if we use this range, if the range is, if more than systems we have, this total range, more than this range, we have a systems, that many systems we have. Then if we cannot assign IP address, what the systems we are having, then the other systems cannot communicate, right? So how to adjust that IP address? So they pulled this range 10, 0, 0. See, 0 to 126, in between 10 is one of the range. 10 is one of the range. 0 to 126, in between range, 10 is the one of the range. So they pulled 10 range, 10,0,0,0 to 10,225.225.225. This is the private range. So this private range we configured here. Okay. Okay, fine. That's good. Nice. So if we configure the private range in the LAN, in the computers in the LAN, then how these fellows will communicate with the internet? How the fellows will communicate? They cannot communicate. They cannot communicate. Hence, they are using private range. Hence, they are using private range. Because these IP addresses are not, the IP addresses are not valid in the public network. So what is the solution then? Yes, there is a NATing concept. There is a NATing concept, network address translation. See, we have a, let me check my public IP address. See, I'm using all private IP address, but still I'm getting internet. How? Because of NATing. So this is my IP address. Let's copy here. What is this range? Which range is this IP address? Can anyone tell me? So this is my which range?
Yes, sir.
Huh? Sorry, I didn't get you. Could you speak loudly?
Class A.
Yes, class A range. How did you identify? Because it starts with 124. So class A range is till 126. So this is a class A IP address. This is a called public IP address. Okay. So these are all missions using private IP address like let me extract this. Sorry, 10 dot, okay, 0 dot 0 dot like 0.1 like or else 1.0. Let's see 1.0, 1.2, or you can 0.2 also. Let's give given to 0.2. I'm just left one. I'll tell you one where. Okay. See, so on. Four, five, likewise. So I'm give you the last number here. 6, 7, 8, 9. Last number I'm just giving last number instead of giving typing all the numbers. It's tough. No. 10, 11, 12. Oh, it's 13. Oh, 13 because of we left one. Interesting. Yeah, 13. Okay. So I'm giving this IP address to this. Okay. I'm giving here 10.0.0.1. This is router IP address. Okay. See, so I assigned the private IP address range in all missions like this, and assigned 10.0.0.1 to router, and there is a public IP address also. So if any mission browse google.com. Let's say this mission is www.google.com. Let's this mission, okay, browsed google.com. So what will happen? The request will go to from here to Okay, the request will go to switch. Okay, from switch to router. One moment. Switch to router. So the request went on 10.0.0.2. So I browse google.com site on this IP. So this IP will take the request to switch and to router. So the router got the request saying www.google.com on IP address 10.0.0.2. But this IP address doesn't work, doesn't route in the public network because it is a private IP address. So private IP addresses are not valid on public network. So what the router will do? Router will perform NAT. NAT means network address translation. NAT means network address translation. NAT means, sorry, NAT means network address translation. So what are the request comes from one of the client for google.com. So this request converted into public to private, converted into private IP address to public IP address. That is called network address translation. So this request translated from private IP address to public IP address, and the public IP address to carry that request to public network and reach the Google server and get the response from the Google server and hand over to private IP address. Hand over to private IP address. So this way NAT will work. So here, what did you understand here? If every system able to communicate with a public network without public IP address. So single public IP address providing internet to multiple missions. So if you don't have a NATing concept, every mission should have a public IP address. So in the world, if everyone using the public IP address in the world, then the IP address will not sufficient. We need IP version 10, 12, 13, 14, keep on growing the IP versions. Because of this NATing concept, only one single public IP address enough to share the internet to multiple systems. This is NATing concept. Hence, we got reduced the IP usage. We got reduced the IP usage in the world. So that is the reason. So without the private IP address and without the NAT, we cannot get reduce the IP usage. So this private IP usage, the private range is to communicate internally. At the same time, they can communicate with the public IP address. This is the private IP address. This is private IP address. So this IP is router private IP address. This is router private IP address. This is router private IP address and this is router public IP address. Router should have a both IP address. What router do? We discussed in the last class. Router is to communicate multiple networks. to enable the communication between multiple networks. So LAN is a private network. This is a private network. This is a private network. And this is the public network. So what router is doing is communicating private network and public network. That is router do. Okay. So that is the reason from every range, they pulled one range for private uses. For private uses. So this is a class A private IP address. Just remember this. And class B total range is 128 to 191. Okay. And private range is 172 dot only 172. Okay. And class C range is 192 to 23. And the private range is 192. The first range is 192. So from public range 193 onwards, it starts from public IP address. The first one is a private. From after 192, 193 is from public IP addresses. So this is the total range and this is the private range. Except this range, rest all IP addresses are public IP address. Rest all IP addresses are public IP address. For example, after 1011 is public. C 173 public. So you remember this private range so that if you remember this private range, rest all IP addresses are public IP address. Rest all IP addresses are public IP address. So this is the private range. Next. So next, see octet format. See octet format is IP address is divided into network portion and host portion. It's a little deep discussion in the IP addressing. This will discuss in the CCNA course. But let me explain. But if you don't understand, that's fine, because there is a concept of network and host portions. See, this is the network portion, 10 dot network. So if you call this is 10 dot 10 network, 128 network, 172 network, 192 network. This is the network. Class A low. In class A, the first letter would be network, and third three are host portions. This is host. Host means computers IP addresses. In class B, network portions 2 and host portions 2. And class C, network portions 3 and host portion 1. So hence, where we will get more IP address among 3? Any guesses? Class A. Because here host portion is more. Host portion means IP addresses. Host portion means IP address. So we'll get a more IP address in class A, and next class B, and next class C. Okay. Coming to network and broadcast address. Network address. IP address will all bits as 0 in the host portion. Broadcast address. IP address with all bits as ones in the host portion. So this is a binary language. You leave it. You don't need unless until you go in for a network administration. Okay. So coming to here, see IP address. You tell me. Okay. You tell me this. This is a identifying valid IP address. Is this valid IP address? Yes, it's a valid IP address. 119. 119 means which range? Class A range. So it's a valid IP address. And this is 172.17.255.255. Is it valid IP address? No, because there is no 255 is valid till 254 is valid. And next, 11.1.0.0 is a valid IP address. Yes, it's a valid IP address. And 195.255.0.255, is it a valid IP address? No, this is 255. And 142.10.0.0 valid IP address? Yes, it is a valid IP address. Okay. So coming to subnet mask. What is subnet mask? So these are the private IP address ranges. Okay. So coming to subnet mask. What is subnet mask? Subnet mask is to make the system understand which IP address is using the system. Let me show you something. ncpa.cpl. Let me open this. Okay, I'm using, see, 10.0.0.5. If I click tab, subnet, subnet mask. What subnet mask is? 255. So this is class A subnet mask. So based on the IP address, subnet mask will generate. So that means the system using class A. So the subnet mask is making understand which IP address are using the system. So for example, 172, like 172.16. Okay. Let me. See, now it is in 255.255.0.0. Okay. So now let me erase this. 192. 168. Okay. Enter. See, now it is. So subnet mask is like a pin code of a. So every I think address has a pin code. So likewise, the IP address should have a subnet mask. Subnet mask is to identify the network. Subnet mask to identify the network, which network the system is using. See, subnet mask differentiate or identify the network and host portion of an IP address, represented with all one network portion, all ones in the network portion, and with all zeros in the host portion. This is subnet mask. Okay, so class A subnet mask is 255.0.0. Class B 255.255.0.0. Class C 255.255.255.0. This is standard subnet masks for each class. Okay. Okay. Now, public IP address versus private IP address. What is the difference between public IP address and private IP address? We are already discussed, but let's see some points which are not discussed so far. So public IP address used on the internet. This IP address used on the internet. Private IP address used within the organization, like private network. It should be unique over the internet. It should be unique. It should be unique within the LAN. So both should be unique. Otherwise, the communication will not happen. Assigned by the internet service provider. Assigned by the internet service provider. So we usually, I'm taking internet. So you're taking internet means you're buying the IP address. You're buying IP address. So the IP address, if you get the IP address, that means you will get the internet. If you got the connection, I mean, you take the connection. The connection means they will configure the public IP address in your router. After connecting the cable, they will configure public IP address in your router, Wi-Fi router. Then only you can communicate with the public network. And here, assigned by the network administrator. Assigned by the network administrator. And need to purchase from the internet service providers. So who are providing internet, we call ISPs. This is also we call ISP. Internet service provider, ISP. We call ISPs. There are many ISPs in the market. Airtel, Jio, BSNL, VSNL, Act. There are many lots of ISPs. There we call ISPs. In the technical word, in technical way, we call there are ISPs, internet service providers. And here it is a free. You no need to buy. It is a free because these IP addresses we can use without paying single NP. So these are differences between public IP address and private IP address. So remember this private IP address range always in your mind. By heart it or else by heart this. So that if you by heart this IP address range, the rest of IP address are public IP address. You can simply say, for example, public IP addresses. Public IP address. Example public. Samples. Sample addresses. I mean, one second. Public IP address. IPs list. See, if you keep the IP addresses, private IP address in your mind, you can simply say which is the public IP address. So, yeah, is this public IP address a private IP address? Public IP address. See, 198.7 is a public IP address. So likewise, you can easily identify which IP address is private IP address and which IP address are public IP address. So there are many public, yeah. See, public IP address. These are all public IP address. See, if any IP address with starting 10. See, if you go up. If you go up, 10.0.0.8. Oh, this is private and public IP address range. Okay, so it's mixed, private and public IP address range. Okay, so we can say this is public IP address and private IP address range up to 223, 192, 172 also there. So, 1 second. I want to see public IP address. The many public IP address available. So this is my public IP address. This is my public IP address. So you can, if you want to see your public IP address, you can see ipconfig.io. Okay. That's all for today, guys. Any questions? Any questions? Okay. Thank you all. Thanks for joining. Have a great day. See you tomorrow.